Okay. So the first question, number 3, says a sleeve of golf balls at the right is a right prism that has 3 golf balls that lie flush against the sides of the box. Do you guys know what it means when it says that they lie flush against the sides of the box? So when we say that something lies flush against the sides, it means that it is just touching the sides. It's not bulging out. We didn't have to stuff it in there really hard, and there's no extra space at the widest point of the golf ball. So it's like a perfect snug fit. Perfect fit. If the diameter of one golf ball is 42.67 millimeters, then find the amount of unused space, the space that is inside the box, but outside the golf balls. So if we have these golf balls, and the diameter is 42.67 millimeters. We said that these golf balls lie flush against the sides of the box. So how wide would the box be if the balls fit perfectly? Yes, 42.67 millimeters. Because the balls just fit there. How wide would the box be? 42.67 millimeters. So I have the length of the box and the width of the box. What else do you think I'm going to need to know about this box to answer this question? The height. Well, this box is 3 balls tall, right? 3 golf balls tall. How tall is each golf ball? 42.67. Yes, you do. 42.67 for one, 42.67 for the second one, and 42.67 for the third one. Which would make this box how tall from top to bottom? 128 point what? You got something close to that, but not exactly. You got 128.01. 128.01 millimeters tall. All right. It says we are supposed to find the amount of unused space, which would be the space inside the box, but outside of the golf balls. So we're looking for this empty white space around the balls here. This part here. If we're talking about the amount of unused space inside the box, do you think we're talking about volume or surface area? Volume. So we need to do, let's see, volume of unused space How do you think I should go about calculating the volume of unused space? What pieces of information would I need in order to calculate this?
Subtract the volume of the golf balls from the volume of the prism.
Absolutely correct. We're going to do the volume of the box minus the volume for the 3 golf balls. So that means we're going to need to find the volume for the box and the volume of the 3 golf balls. So let's do the volume of the box first. It said the box was a right prism, correct? How do you find the volume for a right prism? What's our formula for the volume of a right prism? Area of the base times the height, yes. And what is the shape of the base of this box? It is a square. I'm going to move this down here so that I have enough room. How do you find the area for a square? Side squared. So we have side squared times the height. What are we going to put in for the side? 42.67. We will take that and square that. That'll give us the area of the bottom of the box. And then we're going to multiply that by the height. What is the height of the box? 128.01. Because we've got 3 golf balls stacked end to end inside this box. So grab a calculator. If you need to borrow a yellow one from me, please come up and grab one. What is the volume for the box? What is the volume for the box? You can just read the numbers off instead of trying to figure out the place value.
23, 30, 71.506.
All right, 23, 30, you said 71?
Yes.
0.506. 233,071.506, and that would be millimeters cubed. All right, so that's the first piece of information that we need. I'm going to write that up here. 233,071.506. Minus whatever the volume for these 3 golf balls is. So let's find the volume for the 3 golf balls. First, we have to find the volume for 1 golf ball. What's the volume formula for a ball? Pi r squared is area of a circle, but it's closely related to this. Feel free to go back and look it up. Remember, I am giving you the formulas on the test, so you don't have to memorize them. What is our volume formula for a ball?
4/3 pi r cubed.
4/3 pi r cubed. Do we know r? No. But we can find it. Tell me how to find r. Divide the diameter by 2. So we have our diameter of 42.67. So the radius would be 42.67 cut in half, which would give us what? $21.335. All right, so we have 4/3 pi times 21.335 cubed. How do we cube something on the calculator? What button do we push?
I can't describe it, but it's a triangle without the...
Triangle without the bottom, absolutely. It's called a caret. It's right above the x squared key on your calculator. Right above x squared. What do we get when we do 4/3 times pi times 21.335 cubed? And again, you can just read the digits off if you want to. 40,678.651 millimeters cubed. That's the volume for 1 golf ball. I want the volume for 3 golf balls. Times it by 3, yes. So we're going to do 3 times 40,678.651. What would that give us? What would we have? 122,035 point, and then what was the decimals again? 953. That would be millimeters cubed. This is what we are going to subtract from the volume of the box. So 122,035.953. We will take away from 233,071.506. And what do we get then for the volume of unused space? What do we get for the volume of unused space? Yes. You said 0.553? I got something really close to that, but not exactly. Double check your decimals. Oh, wait, 553. I was looking at the wrong spot on my notes. You're absolutely right. I apologize. I'm so sorry. 111,035 point, you said 553 millimeters cubed is the volume of unused space inside this box. So we found the volume of the box. We found the volume of one golf ball. We times that by 3, and then we subtracted those two pieces. So far, so good?
Yes.
Awesome. Let's go and look at number 4. Oh, you need me to go back? Okay, sorry. All right. Are you good? Yeah. Awesome. Number 4, find the surface area and volume of the object at the right made up of a hemisphere on top of a cylinder. All right, so we want to find surface area and we want to find volume just like yesterday. Since they said surface area first, let's find surface area first. So surface area. I'm going to need the surface area of 2 separate objects. What 2 objects is that? Cylinder and hemisphere. Surface area for a cylinder. Go back and look at the cylinder part of the notes. What is our surface area formula for a cylinder? Go back and look at the cylinder part of the notes. Or problem number 1 from yesterday, we used the cylinder formula.
Lateral area plus 2b.
Lateral area plus 2b. What does 2b mean? 2 bases. What shape are the bases on this object? Circles. How do you find the area of a circle? Pi r squared. So we'd have 2 pi r squared plus lateral area. How do you find the lateral area for a cylinder? How do we find the lateral area for a cylinder? Perimeter times height. What do we call the perimeter of a circle? The circumference. How do we calculate the circumference for a circle? 2 pi r. So 2 pi r h. So 2 pi r squared plus 2 pi r h gives us the surface area for the cylinder. Pi r squared finds what again? Area of a circle. How many circles do we have on the cylinder? 2. One on the top and one on the bottom. Are both of those on the surface of this object here? No. No. How many of them are actually on the surface? Just one, just the bottom. So we don't need 2, only 1. 1 base covered by the hemisphere. All right. So now we have all the pieces of our surface area formula that we're actually going to use. I have pi times r squared. What is r for this shape? 6. Pi times 6 squared, that's the area of the bottom, plus 2 pi times 6 times h. What is h for this object? 8. That is my lateral area. That is the body of the cylinder. The pi r squared is the bottom. 2 pi times 6 times 8 is my lateral area around the cylinder. What do we get for the surface area of the cylinder? 414.69, and that would be feet squared. All right, so that's the surface area for the cylinder. Then we need the surface area for the hemisphere. How much of a sphere is a hemisphere? Half. What's the surface area formula for a sphere? Go look it up. Remember, I'll give you all the formulas on the test. What is 4 pi r squared? That's for a whole sphere. But you told me we don't have a whole sphere. We have half a sphere. So how would we take 4 pi r squared and change it so that it works for half a sphere? 2 pi r squared. Now before we plug in, I want to talk about this for a second, because with the cylinder we had to watch out for both of those bases and whether they were both on the surface. Does a sphere have a base?
No.
No. So if I cut it in half, do I have to worry about any bases?
No.
No. If I wanted the surface area of just half a sphere, I would take 2 pi r squared, and then I would also have to add in that circle base, because a sphere doesn't already have a circle base. I don't have to worry about taking off a base here, because we didn't have a base to begin with. So when I cut it in half, there are no bases. All right, so 2 pi times what goes in for r for the hemisphere? 6, same as for the cylinder. 2 pi times 6 squared would give us you had pi in there twice. How much? 226.194. And that would be feet squared. All right, so now what do I need to do now that I have both of those to find my total surface area? Add them together. So we are going to add 414.69 plus 226.194. And what does that give us? 640.884 feet squared. Nicely done. All right, so that found the surface area of the object. Now we need our volume. So volume for the cylinder. How do we find volume for a cylinder? How do we find volume for a cylinder? Area of the base times the height. What shape is the base again? Circle. How do you find the area of a circle? Pi r squared. So pi r squared, area of the base, times the height. So I'm going to have pi times what squared? Pi times 6 squared times what? Times 8. Pi times 6 squared times 8. What do we get when we do that? What is pi times 6 squared times 8? Yep, 904.779 if you round it. If you write 778, that's perfectly fine. Your answer will just be a little tiny bit different than mine. And that would be feet squared. Or sorry, feet cubed, not feet squared. Feet cubed because it's volume. All right, so there's surface area for my cylinder, or volume for the cylinder. Goodness. Then I need volume for the hemisphere. What is the volume formula for a whole sphere?
4/3 pi r cubed.
4/3 pi r cubed, but this is not a whole sphere. This is a hemisphere. So how would I take 4/3 pi r cubed and make it for a hemisphere? Yes, 2/3 pi r cubed. So 2/3 times pi times what cubed? 6 cubed, yes. What do we get? $452.389 feet cubed. So now we want our total volume. So we are going to add 904, not 909. 904.779 plus 452.389. What do we get when we add those two together? What do we get? $1,357.168 feet cubed, yes. We have one last problem to do in your notes for the entire year. This will finish off your notes for the entire year. Won't be the last problem you have to solve for me, but it's the last one in your notes. All right, so let's look at this problem here. A soccer ball is usually packaged one to a box, and then it says cube. What do we know about cubes?
Their base is a square.
Their base is a square. What else do we know about cubes? You're absolutely right. All the sides are the same size. So the base is a cube and all the sides are the same size. The question says, what is the volume of unused space inside the box holding this soccer ball if the diameter of the soccer ball is 8.8 inches? All right, so let's draw a picture for this. So first I'm going to draw my soccer ball. There's my soccer ball. And then I need to draw the box that goes around it. So something kind of like this. It's not the best picture in the world, but it's going to have to work for right now. All right. This soccer ball fits perfectly inside the box. What do we know? What's the only dimension we know here? We know the diameter of the soccer ball. If this soccer ball fits perfectly inside the box, the diameter isn't just telling me about the ball. The diameter is also telling me what? The width of the cube. What else? The length and the height. What are the length, the width, and the height of this box? 8.8. 8.8 inches for the length. 8.8 inches for the width. And 8.8 inches for the height. What other dimension do you think we're going to need to know about? What about the sphere? What'd you say? Yes. What other information do you think we need other than the length, width, and height of the box and the diameter of the soccer ball? What'd you say? We're going to find the volume, absolutely. How are we going to go about finding the volume for the ball? We need the radius, yes, so that we can find that volume. What is the radius on the ball? 4.4 inches. The radius is equal to 8.8 cut in half. So that would be 4.4 inches. All right. Volume of unused space. How will we calculate the volume of unused space? What did we do before? We subtracted. What did we subtract? What'd you say? The hemisphere? I don't have a hemisphere this time. I'm not talking about on problem number 4. I'm talking about where we had another unused space problem on number 3. Box minus the ball. So volume of the box minus the volume of the ball. Bless you. All right. So first thing is going to be volume for the box. How do we calculate the volume of a box? That's area of a square. We are going to use that, but that's not a volume formula. I need volume for the box. Yep, area of the base times the height. And now here's where we use that other piece, because what shape is the base of this box?
Square.
It's a square. And how do we find the area of a square? Yep, we take the side and we square it. So side squared times the height. How big are the sides of this box? 8.8. So I have 8.8 squared times the height. What is the height of the box? 8.8. So I have 8.8 squared times another 8.8, which gives us what? 681.472, and that would be inches cubed. All right, so that's the volume of the box. Now we need the volume of the ball. How do we find the volume for a ball? Four-thirds pi r cubed. And what did we say the radius was? 4.4. So 4/3 pi times 4.4 cubed. And that gives us what? $356.817 inches cubed. So now we're going to subtract those two. We're going to do 681.472 minus 356.817. What do we get? 324 point, you said 65 what? 65, I got 655 when I subtracted these two. That very last decimal point does not matter though. That would be inches cubed. Depending on how you rounded that, you could get 324.654 or 324.655. Either one would be fine. That is our volume of unused space inside this box. We have a little bit more than 10 minutes for you guys to work on your very last homework assignment of the entire semester. That homework assignment is due when? Tomorrow. Due tomorrow. Homework is due tomorrow. What else is happening tomorrow? Very last skills check of the entire year happens tomorrow. So last homework is due first thing, and then last skills check will happen tomorrow. Then Friday and Monday we will review for your test. You will get the test review tomorrow. And then we'll review in class Friday and in class Monday, and then your test is on Tuesday. All right? You guys have the remainder of the class time to work on your homework.